While a screwdriver or a length of rubber hose can be used to listen to unusual engine noises, pinpointing the source of the noise is much easier using a stethoscope, since this tool is specifically designed to amplify sounds whose origin can often be hard to determine.
Because most engine noises are the result of insufficient lubrication, always begin your diagnosis by checking the oil level in the crankcase. Next, start the engine and observe the oil pressure gauge or indicator light at idle. A low gauge reading or flickering oil light is a strong indication of insufficient oil pressure. When you suspect that an abnormal noise is coming from a belt-driven accessory, remove the drive belt and then allow the engine to run briefly to see if the noise has been eliminated. If you suspect that an unusual sound is coming from the lower half of the engine, move the tip of the stethoscope along the oil pan until the noise reaches maximum intensity. Knocking sounds are common to this area and can be caused by worn main bearings, rod bearings, a cracked flex plate, or crankshaft interference due to a dented oil pan. Piston slap, which is usually the result of excessive piston-to-cylinder wall clearance, is another type of lower engine noise. Unlike other noises in this area, however, a piston slap typically diminishes as the engine warms up. Upper engine noise is generally characterized by a clicking sound that occurs at 1/2 engine speed. When investigating this type of noise, move the stethoscope along the top and sides of the valve cover while the engine is idling. Abnormal sounds that originate from the upper half of the engine are typically the result of worn or misadjusted valve train components. To minimize the time it takes to isolate the source of any unusual engine noise, determine the type of sound the engine is making, the existing engine operating conditions, the noise frequency, and the engine's internal construction.